This week's quiz challenge requires us to compute a probability in a somewhat different setting than what we've seen before. Because in this country of Zuto, what happens here is that the mortality rates are given in 2-year intervals instead of 2-year intervals. We do assume that deaths are uniformly distributed, so that's the UDD assumption, but this is smeared out over a period of 2 years, and that's what's explained here in the hint. And we are given 3 bits of information about some survival probabilities, so that's these red underlinings, which we have to somehow use. And then what we have to actually calculate, is the probability that a person in Zuto, now age 66, will die before reaching age 68. So that's the probability in words. Let us think about what this means in mathematical language. So in actuarial notation, you are aged 66, and it concerns the probability of death, so that's Q, and we have to die before reaching age 68, so we need to die within 2 years. All right, so this is what we need to compute using somehow this information that is available. Now, the information that is given, so these red underlinings, do not seem to give any information about somebody aged 66. Or does it? So it's definitely not the first two, because these concern somebody aged 62 and 64. But maybe the latter one, so let's look at that one in a little bit more detail. So writing it out here, 3.75p, somebody aged 62.75. Well, what age does this person attain? If you go from 62.75 and you live 3.75 more years, you are aged 66.5. So at least this probability somehow contains the probability of somebody aged 66. So this would be the place to start. Now, how to go about it? Well, maybe we would like to use the hint, except the hint looks like it only works for t in between 0, 2. And in our case, t is 3.75, so we cannot even use the hint yet. And also the hint concerns the Q, so the probabilities of death instead of the P, probabilities of survival. So we somehow need to rewrite things in order to use the bits of information that we have. So we know from chapter 2 that one of the most important expressions was the product rule, so what I call the product rule. So if somebody is aged 62.75 and has to reach 66.5, you can write this as a product of probabilities of reaching the in-between ages. So let's start with that. The question is, of course, which ages? So we start by being age 62.75, and the most convenient thing is to reach integer ages in between. And we want to somehow use the hint as well, using the UDD assumption. So the first integer age is 63, but it can be seen from what is given and information is given that we don't know anything about a survival probability of somebody aged 63. We do know something about somebody aged 64, so that's what I now underline in green. Perhaps that is the way to go. So let us do that. So if we are 62.75, we need to live another 1.25 years to reach the age of 64. And then what? How much time is left that we need to survive? Well, at least 2. And this makes sense to write, because now we know that this is known. So we can check. And then, okay, we are aged 66. Hey, so that's also positive, because now we have at least the age we are looking for. how much time is left that we need to survive? So that's 0.5 years, because we need to live to 66.5. Okay, now there's two problems, because we still don't know this part or this part. But perhaps now we are stuck again. So we do know something. That is the first bit of information, that we do know a survival probability of somebody aged 62, and we know that the probability of somebody aged 62 to live another 2 more years is 0.9. But this probability that we don't know, this one is 1.25 p 62.75. This is in the period of that first probability. So perhaps we can write this first probability as a product, as we did before. So what I mean is this: if we can rewrite this somehow as a probability, as a product of probabilities, so we are age 62, and we can reach an age in between, something that we want to know, namely this one, because then we attain the age of 62.75, and we only need to write down what is left. So 0.75 plus what is 2? Well, plus 1.25. And this is exactly the probability that we are interested in. And this is useful because we can rewrite this as the following fraction: 2p62 divided by 0.75 p62. Okay, so let's rewrite this actually. So let's plug this in the main expression, and that gives the following: fraction times 2p64, which we know, times another probability 0.5 p66, which we don't know. All right, so what do we have here? We have some probabilities, these two, that we don't know. And the question is how to compute these. Well, whenever you're stuck in an exercise, and this is general advice for any exercise, it helps to think about the pieces of information that you have used and that you have not used. So we have, in principle, used the first 3 bits of information, so the survival probabilities, and we've also used this one. But we have not yet used the assumption of UDD, right? We have not yet used this bit of information to rewrite these Q probabilities with some t in between 0 and 2. So we have not used this assumption. So why didn't we use it? Well, you can only use it if t is in between 0 and 2. But our t, the one we started with, was 3.75. So definitely we could not have used it before. That was why we wrote it like this, as a product. But for the probabilities that we want to compute, however, t is definitely in between 0 and 2. Therefore, we use the UDD assumption. So using the UDD assumption, we compute the probabilities as follows. The first one is 0.75 p62. Okay, so to use this assumption, we first need to rewrite this into Q, into the 1 minus the probability of death. So that's this. And then we use this UDD assumption to get, well, this is 1 minus, t is in this case 0.75, so we get 0.75 divided by 2 times 2q62. Right, so I just used this UDD assumption. And now, do we know 2q62? Well, we don't know 2q62, but we do know 2p62, right? So that's the the first bit of information that was given, the first survival probability. So if we rewrite this as 1 minus, so this is 0.75 over 2 times 1 minus 2p62. Alright, so this, what does this give? This is equal to 1 minus 0.75 over 2 times 1 minus 2p62, and 2p62 is 0.9, so times 0.1. For the latter one, so there's still one other probability we need to compute, and that is 0.5 times of p66. Now this probability we can rewrite as 1 minus 0.5 q66, and then again we use the uniform distribution of death to write this as 1 minus 0.5 over 2 times 2q66. Hey, now we see that this is the probability that we needed to compute, right? So this is the probability that is actually asked of us. See the thought bubble in the top left. And okay, so this is, we don't know anything other than this, so we need to leave it as it is. So this is, let's say, 0.5 over 2 is 1/4 times q 2q66. So now we can plug this back in, so we can use these two. You can use these two and plug them into this expression to get. So what do we get? I'll write it on the bottom here. We get that 3.75 p 62.75 is equal to, okay, so let's see, 2p62 divided by 1 minus 0.75 over 2 times 0.1 times 2p64 times what we just computed, which is 1 minus 0. Oh well, actually I wrote it already as a 1/4 times 2q66. And if you solve for 2q66, so I will not do these details, it's just some algebra. So solve for 2q66 to get that 2q66 must be equal to 0.1550069, and that is how we solve it. So the interesting, or the hard part of this exercise was that we needed to compute some probability 2q66, which did not occur at all in what was given, but you had to somehow rewrite things in order to at some point find out that this is indeed what comes up by using the hints and the information that is given.